I am Dr.M. Rathamani, PG Associate Professor, PG Department of Computer Science, NGM College, Pollachi. I am going to take about the emerging trends in cloud computing. First, what is cloud computing? Before that, we have to know what is cloud. So cloud is a pool of servers or group of servers. Cloud computing means cloud computing is the on-demand delivery of IT resources over the internet. So it is a pay-as-you-go model, which means that whatever you are using the cloud services, that is software service, infrastructure and platform services, we have to pay for that. So that is called pay-as-you-go pricing. You can access computing power, storage and databases on an as-needed basis from a cloud service provider. Cloud service provider means they are providing the cloud services to the end user. So this is cloud computing diagram. The cloud can provide infrastructure, platform and applications, and the cloud, you can avail the cloud services through servers, desktops, tablets, laptop, phone, etc. So these are the characteristics of cloud computing. Cloud computing includes several advantages, features, so that all the industries and people moving to the cloud. These are the benefits of cloud computing. By using cloud computing technologies, we can save the save the cost. It provides flexibility, scalability, reliability, and collaboration, so that the industries and the entrepreneurs are moving to the cloud. So these are the major three types of cloud computing. First one is infrastructure as a service, second one platform as a service, and the third one is software as a service. Using infrastructure as a service means the cloud service providers will provide the infrastructures to the end users. For example, dedicated hardware, virtual machines, etc. Example for infrastructure as a service is DigitalOcean, Linode, Amazon Web Services, Microsoft Azure, etc. Platform as a service means the cloud service providers provide the running environment to the end users. Examples for platform as a service are AWS, Elastic Beanstalk, Windows Azure, Force.com, Google App Engine, etc. Software as a service provides the software or applications to the end user. Examples for SaaS is BigCommerce, Google Apps, Salesforce, etc. So these are the types of cloud computing deployment models: public cloud, private cloud, hybrid cloud, community cloud and multi-cloud. The first one is public cloud. So public cloud is open to all to store and access information via the internet using the pay per usage method. Example for public clouds are Amazon Elastic Compute Cloud, that is EC2, IBM Smart Cloud Enterprise, Google App Engine, etc. Next one is private cloud. Private cloud means it is private to a single corporate or a list of corporates. It is used by the several organizations to build and manage their own data centers internally or by the third party. The third one is hybrid cloud. Hybrid cloud means a combination of private cloud, which means that the features of private cloud and the public cloud are combinedly used by the hybrid cloud. Examples are Google Application Suite, Office 365, Amazon Web Services, etc. Next, the community cloud, which means that a specific community of people are using this cloud. For example, healthcare community can use this community cloud. Next one, multi-cloud. Multi-cloud is a strategy in cloud computing where companies utilize more than one cloud service provider or platform to meet their computing needs, which is called multi-cloud. Examples for multi-cloud are Amazon Web Services, Microsoft Azure, Google Cloud Platform, etc. Next topic is the emerging trends in cloud computing. After the cloud computing, several other technologies are coming. These are all called emerging technologies combinedly with cloud computing. The first one is edge computing. Edge computing is the practice of processing and computing client-side data close to the data source, rather than moving it to a central server or cloud-based location. This approach minimizes the latency and bandwidth requirements. So in a computer network, latency and bandwidth, we have to minimize the latency and bandwidth so that this technology minimizes latency and bandwidth. With the advent of 5G, it is easy to achieve fast processing and it minimizes the latency little more. So this diagram shows edge computing. In edge computing resides in between Internet of Things and the cloud. Instead of storing the internet data generated from Internet of Things, the edge computing can store that data. So the data transfer limit is closer to the data generated place, so that automatically the latency and latency will be minimized. So edge computing, there are several edge computing applications. The first one is autonomous vehicles. Autonomous vehicles generate large volumes of data and we need real-time data, so that edge computing can be used for autonomous vehicles. Real-life use case for autonomous vehicles are Tesla's autopilot system is an example. The second example is healthcare. There are lots of healthcare data will be generated from medical devices located at doctor's office, hospitals and consumer wearables. These data can be transmitted over long time, means it will be a drawback, and latency also high, so that they are using edge computing in healthcare technology. Example for that healthcare department is GE Healthcare Clinical Decision Support System. This system uses edge computing to transfer data in healthcare systems. The third one is manufacturing and industrial process. This manufacturing and industry is also generating large volumes of data. This data are stored in edge computing technologies. Then streaming services and also content delivery is using edge computing. The next one is fog computing. Fog computing means fog computing is used in between edge computing and cloud computing. It allows data to be temporarily stored and analyzed in the computer layer between the cloud and the edge. This diagram shows fog computing. The fog computing places in between cloud computing and end devices. So this is the difference between edge computing and fog computing. In edge computing, we use billions of systems. Fog nodes include millions of systems, and the cloud data center include thousands of systems.